In this session, I'm going to be showing you some approaches for introducing event-driven architecture patterns into existing application environments. The idea for this session is that I'm going to show you how you can get started with Apache Kafka, how you can incrementally adopt Apache Kafka, but without needing to immediately go out and build a whole load of new applications or go and start rewriting and rebuilding all of your existing applications. What I want to show you is how some of the features in Cloud Pak for integration make it really easy to start taking your first few steps into an event-driven architecture. Most of this session is going to be demos, but before I get started with those, I want to set a little bit of context because we're talking about making a move from data-centric to event-centric, and sometimes those are presented as if they're opposing ideologies. By data-centric, I'm talking about applications that are built around the data, applications and systems that have an implicit goal of collecting data into one place where it can then be processed. And we often describe this as processing the data at rest, with everything happening around the data. With event-centric, we think about our applications a bit differently. We think about the data as being something that is being processed in flight rather than collecting it and processing it at rest. With these kinds of applications, we're prioritizing responding to the events rather than preserving the data. And we design these systems with that in mind. But it's not an all or nothing thing. These aren't opposing ideologies, and you don't have to just choose one or the other. In practice, it's often better to have a blend of both. You want some of the benefits of data-centric architectures, but you also want to build systems that can respond to events in the moment and be truly responsive. Some of those advantages that event-centric approaches can give you. Adopting event-centric approaches can be daunting to do when you've already got an existing data-centric application environment. And that's the idea for this session. What I'm going to do is imagine that you've got an application architecture like this. You've got a collection of microservices that are interacting with each other synchronously through something like REST calls. And what I'm going to show is how you can start to introduce event-centric thinking, how you can introduce an event backbone into your existing application environment in a way that isn't disruptive and doesn't prevent your existing microservices and your existing systems interacting with each other the way they currently do, but that can start to give you options. By adding an event backbone into an existing architecture, it starts to give you the ability to adopt event-centric approaches where appropriate, while still allowing you to have those synchronous calls between services and applications that you use today. Some discussions I've seen about introducing an event backbone into your infrastructure assume that you have to start with a blank page. They sort of imply that the way to adopt an event-driven architecture is to immediately start writing brand new microservices that know how to publish and subscribe to events. Now, writing those kind of microservices, absolutely there are benefits to it, but in practice, you don't want to start ripping and replacing all of the existing microservices you've been building up, or even making major changes to them so they can start working in an event-centric way, because that's risky and an expensive way to start. It's maybe a good end goal for some of your future microservice development, but it's not where you want to get started. You can start to establish an event backbone in your existing enterprise in much simpler, easier, more incremental ways. So for the purposes of this session, I have set up a new Kafka cluster using event streams from Cloud Pak for integration. It is a brand new out-of-the-box Kafka cluster. I haven't done anything to it yet. There are a couple of topics here, but those are the topics that you get out of the box that provide storage, provide persistence for features like the schema registry. So this is, imagine, like I say, this is an enterprise adopting Kafka for the first time. They've got an existing set of applications, and now they've introduced an event backbone and they're looking to start adopting it. And that's what I'm going to be showing you today. Many of your existing applications and systems and microservices are going to be processing things that logically you could think of as events. It's often really cheap and easy to configure those systems to start contributing what they're already doing to your brand new event backbone, and to do that in a way that doesn't disrupt what those systems are already doing. So for the purposes of this demo, I'm going to be using GitHub to represent some existing critical enterprise system in my business. So imagine that this is some system that my business is already using, and it's recording changes that are being made to some resources in my enterprise. And the changes to those resources that it's managing, that it's tracking, it might make sense to think of those changes as events. So that's my first demo. So what do I need to do? First, I go back to my brand new Kafka cluster, and I'm going to create a topic. I'm going to call it GitHub. And this is the topic that's going to be holding that stream of events of changes in my business system. I'm not going to do anything to configure the topic. The defaults are good enough for now. So now I have my first topic. It is something that I can use to record my stream of events changes in my enterprise. So the next thing I'm going to do is create some credentials that I can use to get the events onto there. So I'm going to click on generate credentials, and I want a username and password. I'm going to call these GitHub credentials. I need it to be able to produce a message, to send a message to the topic. The only topic I want it to be able to send to is this new GitHub topic. And then the defaults are good enough for everything else. So for this demo, I'm going to be using a webhook. So if I go back to GitHub, an increasing number of enterprise systems support webhooks. You can configure them to make an HTTP call when something happens. So if I click on Add Webhook here, what this is offering me is every time something happens in GitHub, happens in this repo that I've set up, it can make a post to a URL of my choice with the details of that event. Now, one of the things that Event Streams gives you is what's called the REST producer. It provides a REST interface, an HTTP interface for getting messages onto the event backbone using this URL here. So I'm just going to copy that and then paste it into there. I can choose what shape of the data I want. I'm going to go with Json because that makes it nice and easy. And for simplicity, I'm going to put the credentials into the URL here. So I'm going to take that username that I created and put it there, and get the password that was generated from there and put it in here. To save time, I'm not going to bother with SSL verification. I'm just going to click on Add. So you can see the message at the top that it sends a test just to make sure that the connectivity is all good. So if I go back to the topic, you can see that test message has been generated. And here it is. It's just some metadata about the config. So I'm now ready to go. So if I show you that in action, if I go back to my critical business resource, and I'm going to make some change to it. So I'm just going to edit this file. Something has changed. So because I've configured GitHub to use that webhook to make an HTTP call to my event backbone anytime something's changed, if I go back to my topic, you can see it says one new message has arrived. If I click on the refresh, I can see the new message, and here it is here. It's a bit difficult to see all on one line, so I'm going to copy that to an editor here, and then I can format it and make it easier for you to see. So what I've got here is an event that describes which repo the change happened in, who it belongs to. I've got details about the commit, the name of who it was who made the change, the commit ID. So if I go back and look at GitHub, you can see the full commit ID is that value that starts 099BE7, and there it is 009BE7. So all of the metadata about the change that has just happened was pushed to my event backbone. So why might you want to do this? Well, like I said, imagine that GitHub, it's representing some critical system in my enterprise, and it's recording and managing changes to really important business resources. Well, now that I have a stream of events recording those changes, it could start to enable new innovations. The developers of my enterprise could start writing applications, really responsive applications that can subscribe to receive a notification about that event. Alternatively, developers might want to start replacing some of the uses where they're making synchronous calls to that backend system where they're making repeated calls, perhaps even polling to see, has that business resource changed? Has anything happened? Has the business resource been updated? Now they can subscribe to receive a stream of events for when that resource changes. So it can help them to make much more responsive applications. So to recap, identifying existing interesting sources of events in your environment and starting to contribute them to your brand new event backbone can be done often with nothing more than just simple HTTP configuration. And doing that is a great first step towards adopting an event backbone and event-driven approaches in general. But there are other ways to make the APIs that you're currently using available through an event backbone. For my next demos, I need APIs that will represent existing external third-party APIs that microservices in my business are making a lot of use of. I need something that's going to represent APIs that will allow me to retrieve changing data. But for the purposes of this demo, they're APIs that either don't support or won't allow me to add something like a webhook that I showed you in my last demo. So I've chosen a couple of APIs, Twitter and a stock price API from AlphaVantage. So like I say, imagine that for the purposes of this demo, these are APIs that my business microservices are using. They're making a lot of calls to these external third-party existing APIs. And what I want to do is show you how I can make these existing APIs available on the event backbone. So to do this, the first thing I need to do is create some new credentials for contributing things to the event backbone. So back to event streams. And again, I'm going to go to the Connect panel and start creating some credentials. I'm going to call these Kafka Connect credentials, and I'm just going to give them permission to do everything in the interest of time. And I'm going to use these credentials to start up Kafka Connect. It takes a little moment to get started, so I'm just going to start it first, and then I'll show you what I've done. So Kafka Connect is a standard tool in the Kafka ecosystem for getting data from external systems into your Kafka cluster. So I'll show you the configuration here, but actually first I'll just show you where I got it from, because I set this up ahead of time. If I go to the toolbox, one of the options here is set up a Kafka Connect environment. Click on setup, and it lets you download a zip that has a lot of the config already ready for you out of the box. So I did that before I started this session. But what you can see here is it's got information about how to connect to the Kafka cluster. So I can find that in that Connect tab. Because I'm going to run Kafka Connect inside the same OpenShift where the event streams Kafka cluster is running, I used the internal address. I told it where it should store its config. So this allows me to scale up the Connect cluster to run in multiple pods and have a shared set of config. It also means that the work it's doing is persisted. So if I restart those pods, it won't lose anything because all of the status of how far it had got to and what it was doing is persisted on topics. And actually storing all of this in topics is really convenient because it means you don't have any more new storage needed to run this. The other thing I needed was to build a custom Docker image. Now that zip file that I download from the Event Streams UI gives me everything I need to do that, but I'll show you what I had to do. The Docker file is really, really simple. I start with the Event Streams Docker image as a base, and then I just copy in some extra jars because there are thousands and thousands of connector options out there. I'll show you where you can get some in a moment. So Kafka Connect just comes as the framework that's able to run connectors, but to build your custom Kafka Connect image, you need to bring in the jars that you want. So I'm going to be showing you a few examples so you can sort of see that. For the stock prices one, I grabbed the jar, and like I say, I'll show you where you get these in a moment. But what I've got here is a custom Docker image that has the connectors I'm going to be using for this demo. So actually, let's talk about where you can find these connectors now. A good place to start is the event streams documentation. So you'll find here a range of connectors to help get you started. But because Kafka Connect is part of the Apache Kafka open source ecosystem, there's a whole ton of additional third-party connectors out there. whatever system you want to connect to, whatever API you want to sort of bring into the event backbone, into your Kafka topics, there's probably a connector out there already that supports it. But if there isn't, it's not hard to write your own too. In fact, the stock price connector I'm using for this demo today is one that I wrote. Kafka Connect does all the hard work of getting data onto the Kafka topic. All you have to do is write the code that's specific to your API, that knows how to invoke that API and bring back the data from it. So it doesn't take a lot of code at all to write a new connector. But now that I've got Kafka Connect up and running, I now need to start adding some connectors to it. So like before, I'll do that first, and then I'll show you what I did. So again, it's just a tiny bit of config. So for the Twitter one, if I show you that here, because like I say, you're building this custom Docker image that has a whole ton of jars in it, you just have to tell it which class it is that you want to run. So for this one, I'm running the Twitter connector. I tell it what search I want it to do. So any tweets that mention the word Kafka, I want it to send to the topic called twitter.kafka. I've put my API key for the Twitter API in a secret that I'm going to sort of point at here, so that way you don't get to see my API key. And I'm telling it that I want it to put the tweets that it finds onto the topic as a JSON object. The stock price one is pretty similar. If I show you that connector, again, only sort of 19 lines of YAML. I just tell it which Connect cluster I want it to run it on. I give it the class name for which connector I want it to run, and then a few config values. So this is going to be showing me stock prices for the IBM stock, and it's going to be putting it on a topic called stockprices.ibm. Now, you're not expected to sort of learn and know exactly how to write all of this config. You'll find with any connector that you choose, that you find, whether it's in the IBM catalog or just in sort of open source, they will give you all the configuration you need that you'll put in there. So it's just a matter of going to the documentation, grabbing all the keys and choosing how you want to configure it. So now that I've got my two connectors started, if I go back to my Kafka cluster, I'm expecting to see two new topics, a stock prices IBM topic and a twitter.kafka topic, that each of these connectors is going to be sending messages to. So if I go to my list of topics, just close that, so I can see my two new topics here. So let's start with the stock prices one. You can see that it's started grabbing a stream of events, and now every time there's a stock price change for the IBM stock price, that will be produced as an event to this topic. And if I check the Twitter one as well, you can see that even while I've been talking the last couple of minutes, there have been a few tweets that have mentioned Kafka. But let's try adding another one and just check that it does really work. If I move that over here, if I hit on tweet, the connector should receive that message from the Twitter API and produce it to my Kafka cluster. And there you can see one new message has arrived. So if I hit on refresh, I can see that message that I sent, testing a Kafka connector, and a whole load of metadata about that event, what app I used to send it, my username, where it thinks I am, all of that sort of stuff. I'm just going to delete that message because that looks a bit weird. So, like before, there's a whole load of benefits to starting to contribute your existing APIs to the event backbone. As I was mentioning before, it can spark new innovations, giving developers a way of interacting with the data that they already need and they already use, but giving them a different way of consuming that. That different consumption model can often spark new ideas for new and different microservices. And partly that can come from the new capabilities that the event backbone will bring. So, for example, a Kafka topic has an event log. It has a history of all the events that have happened before on this topic. It's not just about fetching the current data, like the current stock price or the current most recent tweet that mentioned the word Kafka. There's an event log of all the events that have come before. Kafka supports replaying historical events. And that ability might get your developers to think of new things that they could create that maybe wouldn't have been as easy to do with the API alone. You might also find infrastructure benefits for doing this. So consider a scenario where those existing APIs are really expensive to invoke. And that could be expensive in terms of computing resource. If you're hosting that system yourself and you want hundreds of applications to be able to retrieve data from it, that might make that backend system really expensive to provision. You might need to really scale it up. Or it might be expensive in financial terms. Maybe if you have to pay for those API calls to get the stock price or the tweet, then having just one application make that API call, the connector, make that API call once and put that data on the event backbone, that makes it available for hundreds or thousands of client applications to be able to make use of that across a huge number of microservices. So you might find that starting to distribute that data, distribute those events from an event backbone, brings you savings, infrastructure or financial savings. And as I mentioned, there are a huge number of connectors that are available to enable this kind of pattern. I showed you the IBM catalog, but as I said, if you search for existing third-party options, you'll find there's hundreds and thousands of other connectors out there that you can find. And for those rare cases where you can't find an existing connector that meets your needs, it's really simple to start writing your own. It's not just APIs and applications that can become an effective event source. If you've got a data-centric architecture, you've almost certainly got a database or two included in there somewhere. So event enabling your databases is another really good way of starting to introduce an event backbone. For the purposes of this demo, I've set up a Postgres database. It's a tiny little toy demo database with just a single table. But for the purposes of this, imagine that this represents some critical backend database in my enterprise. So what I've got here is a table called demo in a database called archdemo, and it has quotes from cartoon characters. So what I'm going to do is attach a connector to this using the same Kafka Connect approach I used before. So like before, I'm just going to start the connector running, and then I'll show you the config that was involved. So like before, it's a tiny bit of YAML that configures how the connector should connect to the database. So the first thing I need to do is tell it which connector to use. I'm using the Postgres connector from Debezium, which is an open source project of connectors, and you can find them in the Connect catalog here. So it's this connector that I'm using here. The config I needed was to tell it basically where my database is, how to connect to it, credentials that it should use to connect to it. And again, I put them in a secret ahead of time so that you wouldn't see the details. I don't need to tell it what topic name to use because it's going to generate topic names based on the database name and the table name. So I'm going to have a different topic for each table in my database that it's going to be event enabling. The other difference from the connectors I showed you before is instead of using Json like I did for the last few demos, this time I'm going to use Avro. Avro is, if you haven't seen this before, this is a way of describing schemas for the data that's being produced to the Kafka topics. So what this means is when the connector first connects to my database, the first thing it's going to do is query that database table for the structure of the table. So it's going to see that I've got a table called demo and it has 3 columns and unique ID is an integer and message is a string and so on. And you can see here what it's done is it's produced a schema here. Actually, if I click into it, you can see that what I've got here is a schema that describes the fact that I've got a unique ID that's an int and message that's a string and so on. As you start to scale up your use of the event backbone, this kind of thing is really useful because it means that developers who maybe don't have access to that database and don't know the shape of the database table, they can rely on this schema to give them a definitive idea of the messages that are going to be produced to this topic. And if I go and look at the topics, you can see that I have new topics here. And as I was saying before, the topic names are made up of the database name, the schema name, and the table name here. And what this is going to be doing is recording changes to my database. So for example, I've got some changes ready here to go. If I comment that out, rather than make you watch me type in SQL. I'm going to add a new cartoon. So if you watch cartoons in the 80s, this one might be familiar to you. Batfink, my wings are like a shield of steel. So if I run that query, so that's inserted a new row into the database. And what I'll get here is a new message. And it's a bit tricky to read because this is serialized using that schema that I talked about. So it's a really efficient sort of binary format. And the schema makes it really easy for you to deserialize that. So let me show you what that looks like. I have got a Java application ready ahead of time. And this Java application is going to receive messages from the topic, and it's going to print them out in a slightly nicer format. So if I make another change to the database, I'm not going to try and think of another cartoon quote, so I'm just going to do hello, hello, testing, and hit play. So this has inserted it into the database. The connector will see that change, and you can see I receive a message from the event backbone that something has been created. That's what the C stands for, and it gives me a copy of the new row on the database. If I make a change to a row, and you can see I've got that ready as well, so I'm going to update this message from South Park to add some exclamation marks on the end. If I hit play, I've updated a row. You can see here I get another message from the event backbone, an update with the latest copy of the message. And finally, if I delete a row from the database, I get a delete message from the event backbone with the ID of the row that was deleted. What I've got here is change data capture. Anytime something is created or updated or deleted in my database, a notification is produced to my Kafka topic. As I said before, making your existing critical data available in a new form, in a new consumption model, is a really great way to start enabling new innovations. And it's a really effective step towards starting to adopt event-centric benefits. Because imagine that this database table wasn't a table of cartoon quotes, but was a table of orders that have been made. Applications at the moment might be querying that database to see if there's a new order. But now there is a stream of events on the event backbone. An application can really easily subscribe to be notified when there's a new order, and it can then go and take some action. So you've enabled really easily, really cheaply, really quickly, you've enabled a new microservice to be very, very responsive to new orders. And you've done that in a way that hasn't had to change any of that existing database or change anything that currently connects to or produces or writes to that database. By connecting that connector, it's a very non-disruptive way of starting to expose the data in that database in an event-centric way. It's not just about getting events onto the event backbone, because that is only one part of the story. Adoption of an event backbone will also include finding simple ways of processing events, storing events, and building systems that can respond to the events. And all of those can be started very simply as well. For my last demo, I'm going to show you an example of building, getting events from the event backbone and pushing them to an application as a notification. And I want to show you that even doing this kind of thing is really very simple too. For this demo, I'm going to be using Slack as an example of an application that I want to receive a notification about a change. And the change I'm going to use is that GitHub repo from before. So what I want to do is show you how this enterprise system that is recording changes to my critical business resources, that change can be picked up as an event, go onto the event backbone, and that can be pushed out to my existing application as a notification. So to do that, I'm going to be using another part of Cloud Pak for integration. I'm going to be using App Connect. So I'm going to create a new event-driven flow. So that's the building flows that can react to real-time events. So I want to start this flow with an event on my Kafka event backbone. So I'm going to choose Kafka and choose the new message event. And the topic I want it to be watching is the GitHub topic. The defaults are fine for this. Now, because I configured GitHub to send messages to the topic in a JSON format, the next thing that would help is if I parse it using a JSON parser. So what value do I want it to parse? I want the payload from the message, so I'm going to choose that. And then I need to give it an output schema, but rather than write one, I'm going to generate one automatically. So if I go back to the topic, I can take the most recent message, and if I copy that as an example, then I can paste that in there and use that to generate a schema. So what I've got here is a schema that knows about the fields, and it's made a decent guess about the data types. I could tweak that if I wanted, but that's good enough for me. So now I have a parsed copy of the event from the event backbone. I want to send it to my application as a notification. So I'm going to pick Slack, and I'm going to choose, I'm going to choose a message, send a message to the channel. So I'm just going to pick where I wanted to send it. So I wanted to send it to that demo channel that I showed you before. So I'm going to choose demo. And now I just need to choose what I want it to say. So there has been a new change to critical resource. The change was made by, so let's, and there's a lot of fields in the messages that GitHub sends, but I'm going to go with the username of the committer who made the change, and has the title, and if I get the title from the event as well, so again, if I, somewhere in here, there you go, it's called message. And I think that's good enough. So now if I start this flow, so to show you that working, I just need GitHub open over here and my Kafka topic. So I'm going to move that here so you can see both at once. So I'm going to make a change to my critical something has changed again, not a very imaginative change. Demonstrating Slack notifications, and then I'm going to hit commit. So that change is pushed to the event backbone and will appear on the Kafka topic as a new message, and you can see that here. That will be picked up immediately by App Connect, and you can see that event has been picked up by App Connect and pushed to Slack as a notification here. There has been a new change. The change was made by the username and the title that I used there. So to recap, adoption of an event backbone also needs to include being able to respond to events. And that's also easy to do in a low-code way with just some simple configuration. And those are all the demos that I wanted to show. As I said at the start, my goal was to hopefully give you some ideas. If you've got an existing data-centric application environment, I wanted to show you how you might get started introducing an event backbone into that application. All of my demos were very, very simple, but that was intentional. My goal was to show you how, with nothing more than simple either HTTP configuration or some connector configuration, either by writing some YAML or using a low-code environment like App Connect, running things like webhooks and connectors, you can start to make your existing APIs, your existing data, your existing databases available for consumption on an event backbone. You can do that in a way that won't disrupt what your existing microservices are doing or your existing databases. It's just taking what you're already doing and making them available for consumption in a new way. And I talked about how that can enable a whole load of new innovations, creating new types of applications, new, more responsive applications that are based on the data that's available in your existing APIs and your existing systems. And I showed you how you can do all of that without disrupting what you're currently doing and without a huge amount of investment in development of new event-centric microservices, because it can all be done through simple configuration to get you started. So I hope that was useful. If you would like to know more, please do get in touch. If you'd like to embark on this kind of project, Client Engineering is an organization in IBM that can help partner with you to do this, to adopt new technologies, to do this kind of transformation work And we have developers who will pair with you to help you get started on this path. So if there's anything like that that we can help you with, please do let me know.